But at this point, I mean, it would not be an exaggeration to say that billions of people around the world are, Envoy is in their daily experience. We're about to get into hot take territory. If LLMs are very useful for writing code that you're working on, you're probably not working on very interesting things. How rigorous do you have to be is honestly, typically it's a function of what is the impact of failure. What I'll start by saying is that microservices are human. They're a solution to a human problem, not a technology problem. I am motivated by proving people wrong. It's like there's nothing that motivates me more than being told that something is not possible.
Okay, cool. So it is my pleasure to have Matt Klein on the From Scratch podcast. Matt is an industry vet of software engineering with experience at Twitter, Amazon, Microsoft, and most notably, he worked at Lyft, where he created this open source project that is pretty much used across the board, Envoy, for distributed infrastructure. So Matt, thank you for coming onto the podcast.
Nice to meet you. Thanks for having me.
Yeah, so before we get into Envoy and BitDrift, because we're really excited to talk about those things, I kind of want to just go through your background, kind of your early career, because I think your engineering journey has been phenomenal, and I think you've worked at some really interesting places at interesting times, so I'd love for you to get into that.
Yeah, sure. So I've been in the industry for approaching 25 years, which at this point makes me feel very old. So I guess I am getting very old. And I started my career straight out of college working at Microsoft, actually. And this is a long time ago. This is in the early 2000s. And really, the thread of my career has been mostly in low-level systems. So when I started at Microsoft, I was actually working on Windows Phone, which I'm sure many of your viewers might have actually never heard of it. This is before iPhone. So this was a visual smartphone, and it's a whole separate conversation as to whether Microsoft should have had the iPhone business. Probably won't get into that, but I started my career working on Windows Phone on operating system stuff. And then also dating myself, I worked at Microsoft on HD DVD, which was actually a competitor to the Blu-ray specification. Some of your viewers have probably never even seen a Blu-ray, but this is going way back in time. And then I worked on the Windows NT operating system. So that was about 5 years, and it was really all low-level systems. I actually left Microsoft to start my own company. So this is when I was in my early 20s, and it was in the video streaming advertising space. And it was a total failure, learned a lot about what not to do starting a company. So I spent a bit of time doing that. After that, I actually worked at a defense contractor for a year, also working on low-level systems. And that was fun, learned some stuff, realized that the government on the defense space is not for me. And then from there, I worked at Amazon. That was very early on in EC2. I think at the time that I joined, all of AWS was probably 200 people, and EC2 was like 50. So, it was pretty crazy time. Saw a lot of exponential growth there and learned absolute ton. I was working on hypervisors, virtualization, networking. From there, I went to Twitter. And I ended up building Twitter's Edge proxy, which was really the precursor to Envoy. And that was where I switched from very low level systems, again like operating systems and hypervisors and those types of things, to working more in the distributed systems application networking space. So I was first exposed to service networking and HTTP edge networking and those types of things. So I did the Edge proxy there, and then from there I went to Lyft. And I've told this story many times, but the short version is this is 2015 at Lyft, and Lyft, like many companies of that era, for better or worse, maybe worse, we talk about that also, was moving from a monolithic to a microservices architecture. And back then, the tooling was less mature than it is today, and Lyft was having a lot of troubles. Based on my previous experience at Twitter, we ended up building Envoy and worked a lot, obviously, at Lyft, helping to make Lyft successful in its monolith to microservices transition. And then we open sourced Envoy in 2016. The rest there is history, as they say. And Envoy became very popular, and I'm sure we'll talk about it more. And I spent, the next long period of time working on Envoy and helping to evolve that at Lyft and then within the industry. And then while I was still at Lyft, we started working on what is now BitDrift. And then in 2023, we spun BitDrift out of Lyft into an independent company. So we raised venture capital, and now we're an independent concern. You know, BitDrift is an observability company, but one thing that I think you'll see in my career, at least for the last like 15 or so years, is that I've very much been a software developer, but I also consider myself a reliability engineer. I've spent a lot of time working on operating systems. So I like building systems, but I also like operating systems. Observability is very near and dear to my heart. And, I've had a lot of experience as an observability user, and now I'm obviously a vendor, but, I think that experience is based on a lot of previous experience. So that was the whirlwind tour. I'm sure you'll have follow-up questions, but that's the brief summary.
One of the things that I was reading from your blogs that I think was really interesting, you talked a lot about the cultural differences, especially early on in your career of working at Microsoft versus going to Amazon. I think you had a specific phrase like shrink wrap, like software. Like basically, at Microsoft, there was this philosophy of basically shipping software that just worked because, I mean, I guess software used to be something where you didn't get like instantaneous updates all the time.
Yep.
You had to ship something that
Yeah.
just worked.
Yeah.
But then you went to Amazon at the AWS stage. So what was the cultural difference like there?
Yeah, I think Microsoft has obviously evolved a lot. So what I'm going to talk about now is the Microsoft of almost 25 years ago. So I just want to be clear that I'm not talking about the Microsoft of today. But when I started at Microsoft in the early 2000s, this was coming out of the era of what you just said. I mean, people bought CD-ROMs of software, and that was the software. It's like once it was out, I mean, it basically wasn't updated, or they had to update the CD-ROMs and send them. Like there was no such thing as internet updates of software. So Microsoft, came out of a culture of where you work for a long time and you ship this thing and then it's done. It's like you might do some updates, but that's pretty much it. And it had built up a structure to support that, meaning, there was an engineering organization and then there was like a testing organization. And back then, a lot of testing was actually manual. The industry hadn't moved towards fully automated testing yet. So Microsoft had a lot of structure to be very rigorous about shipping software because mistakes were so costly, right? It's like if you shipped a bug, they literally would have to go and make new CDs and send those out and get people to do updates. So it's hugely costly. And, I learned a lot from that level of rigor, especially for the people that were working on the operating system. It was very, as a young engineer, it was very eye-opening to me to see what, all the testing that went into it and how rigorous they were about code quality and cleanliness and all of those things. And when I went to Amazon in 2010, I'm gonna be perfectly honest, it was shocking to me. I mean, it was just like shocking to me at the time. At least from my perspective of how low the quality bar was, like how willing, they were willing to ship bugs and then just fix them later. And I'll say now that's a very naive perspective, right? It's like having been in the industry and seen how we ship internet software at very high rates. Amazon is incredibly successful and was very successful in doing that well. But, it's at the time, it was just very, very, very shocking to me for that. And so seeing those two sides of the culture, on one side, the Microsoft side, very slow, very rigorous, like big attention to quality, that was what I had started with. And then at Amazon, seeing, frankly, early on in the chaotic startup days of AWS, very little attention to quality and just ship it, ship it, ship it, fix it, fix it, fix it. Those are two very different cultures. both very successful, right? I mean, like there's nothing wrong with either. And I think for me, I think having been exposed to the rigorous Microsoft culture and then exposed to the chaotic startup culture, it actually was very formative for me because it showed me both sides. It showed me how to be rigorous, but it also showed me how to ship and how to move quickly. And I think for me, I do have personally a very high quality bar, but I also know what it means to ship, and I know what it means that sometimes you have to just throw some hacks in there. So I think just like early on, being exposed to both sides was very formative.
Yeah, I mean, what's so interesting is that, I mean, Omeed and I are pretty new software engineers. We're just getting into the field. And so I think like we've seen the Y Combinator approach and the Silicon Valley approach of just ship
Yeah,
it and then fix it quickly when
sure.
it breaks.
Yeah.
And I think so I guess like it's really interesting because you had that rigorous background. And I'm wondering like, do you feel like, because it feels like the industry really has moved in that direction of we need to just ship things quickly and we'll kind of
Yep.
like figure it out.
Yep.
Do you think we've lost something of software engineering, like as a craft with
I
that?
do. Yeah, I do. And this comes back to what I was saying, which is that I don't actually think it's mutually exclusive. I think, as in all things in life, and especially in software engineering, nothing is black and white. It's all shades of gray, right? It's like there's this continuum between taking 4 years to get something, quote, perfect and not shipping it, right? Versus, shipping a pile of shit. Sorry, I actually don't know. Is it
That's
okay
fine.
for me to curse?
That's-
You know, is it okay to ship something really bad? Like, there's no right answer. I mean, it's in my opinion, it's wrong to ship something that's obviously broken. It's also wrong to wait 4 years and not ship anything. And what it comes down to is honestly personal judgment and experience and seeing both sides. And the longer that you're in the industry, you start to get a feel for when is it worth it to spend a little more time on quality and when is it time to just ship something and put it out there. And anyone that tells you that they have a formula is just wrong. Like, there is no formula. It honestly is subjective judgment, and based on so many things, based on where are you at in your product market fit life cycle, what are the repercussions of shipping bugs, all of those things. Like, there's no perfect answer.
Yeah, because that's really interesting. Because Laith, the reason he brought that up was we recently read this post by Gary Tan, who is like the president of Y
Yep.
Combinator, and he was saying how in the winter 2025 batch, I think 95% of the code that was shipped and like applied with was AI generated. And
Yeah.
that was a statistic that just blew our minds because, I think a lot of people, when they think of starting a company maybe like 10 years ago or 20 years ago, is like, I need to be like a software engineer that's rigorous and I need to pay
Yeah.
attention to what code I'm writing so that I can actually get
Right.
funded, for example, in Silicon Valley. But the fact that 95% of the winter batch is AI generated code, what does that say about the future of software engineering and the future of startups? So I'm really curious on your thoughts on
Yeah.
that.
I mean, this is a very complicated topic, and I'm going to admit that we're about to get into hot take territory. And what I'll say is that, look, I use LLMs. I use them for certain things. So far, I find them to be very effective. For the code that I write for my company on a day in and day out basis, I find them almost useless. And the reason being is that, again, like, I'm no expert, but LLMs are trained on a corpus of technology and a corpus of existing technology. And my general feeling, this is going to be hot take number one, is that if LLMs are very useful for writing code that you're working on, you're probably not working on very interesting things because it means that someone has already written that code, right? Because, like, if the LLM is able to produce it, it means that there's a corpus of existing technology. Now, with that said, the reason why this is tricky is that for something like a Y Combinator batch, if you're working on a consumer oriented product where you're shipping an app, right? And your app is based on some ideas but the app itself is mostly just constructing some views and some other stuff. Sure. I can totally believe that LLM wrote 95% of the code and people are tweaking various things. And if you're looking for product market fit for a consumer app, great, that's fantastic. If you're working on what I would call like novel low level technology, and if an LLM wrote 95% of your code, I actually find that impossible to believe. It's just not possible because either it's not novel or they're lying, right? I mean, it's like, because that's just not the way the LLMs work. So I think what's important to keep in mind is that LLMs themselves are, powerful autocomplete technology, right? That are trained on an existing corpus of data. So coming back to what I use them for, where I find them personally extremely valuable, is when I'm writing SQL, amazing. I mean, it's just amazing. It's like I tell it in human language, I want to query this, help me do this database table layout, do this, do that. There's such a large corpus of training data that it works amazingly well. Or I'm not very good at writing bash scripts, quite honestly. Historically, my rate of coding of bash scripts, I'm not joking, is like 10 minutes per line. I always get the syntax wrong. Like, it's terrible. It takes me forever. LLMs, it's like my bash scripting rate goes to almost instantaneous. I'm just like, write me a bash script that does this, and it just does it, because it's not that novel, right? It's like something I have to do, but it can just do it for me. So to me, LLMs are a tool, and they're more or less useful in different areas. And I think that, I would take what Gary Tanner, whatever his name is, said, just with a grain of salt, in the sense that it's just dependent on the type of technology that people are working on. And in some places it's going to be useful, in some places it isn't. And over time, will it get better? Sure. I mean, the technology, I'm sure, will continue to evolve. I do have concerns that others have raised, which is that, these systems are trained on existing data. And if no one knows how to make new data, it's like, over time, where's the corpus of training data going to come from, right? It's like, if people are going to move into a world in which theoretically the LLMs write code, but someone has to review it and make it work, where are those people going to come from? How are they going to learn how to actually make it work? So like, it's a pretty tricky thing.
I think what's interesting as well in this conversation is, I mean, you kind of were alluding to this earlier, but there's this kind of loss, or like, let's say there is some degree of loss in the quality of software nowadays as it's getting shipped faster and faster and faster. Maybe we're losing that like really critical part of software engineering. So I wonder kind of like, if we're having that trend going on, and then we're also having the trend of LLMs writing an increasing amount of code, then how many Matt Kleins are we realistically training in the world anymore where they can have that Microsoft experience?
I don't know. I mean, I'm pretty pragmatic when it comes to these things, in the sense that there are people that you'll talk to, that they love the craft of software engineering and all of these things. And don't get me wrong, I do like programming. I've always liked programming. I'll probably always like programming. But programming is, for the sake of programming, is actually not why I do my job. I mean, it's like, unlike I think other people, or at least what other people claim online, I do no side projects. Like, I don't do, like, it's not a hobby for me. The reason that I do this ultimately is because I like having impact. I like people to use what I do, right? So from my perspective, for me, if I'm having impact, it doesn't matter to me whether I wrote the code or whether an LLM wrote the code or something. So I'm just saying that I think at the end of the day, we have to look at the outcomes and not the inputs, right? So it's like, I think it's an interesting discussion about whether the outputs will be as good over time, right, if people don't know how to do it. But that's a little more speculative, just from the perspective of, I don't know, it's like, I actually don't know. Will the outputs be worse? Maybe, maybe not. Who knows? I mean, it's like, I think these things are going to take a lot of time to sort out. I'm just saying that, to me, on its own merit, there's nothing wrong with LLMs. It's a tool. It's a tool, like an editor and a debugger and all of these things. And the output, what people produce, to me, is the most important thing.
Yeah, I think definitely there's a lot of discourse on this.
Yeah, I don't know.
Omeed and I have a
Yeah.
lot of like ML like experience, so it's like there's two camps of people. You have the Jan LeCuns of the world that are saying that the current architecture can't reason, and then there's other people who are saying we already have something that is human level or even better. So I think
Yeah.
it's a mess.
The only data point that I can tell you is that, for me, for the type of technical work that I do, the LLMs are nearly useless. Meaning, like, on the core technology, it's like they're not going to replace my job anytime soon. Do they help me go faster in certain areas? Absolutely. Like right before this call, I was just like wanting to test something with curl and some API or whatever. And I was like, hey, Chat GPT, show me the curl command for, it's like, in 30 seconds, I got the answer that I would have spent 15 minutes messing around with looking at man pages or whatever else. So is it productivity boosting? Absolutely. Like, will it get better over time? Absolutely. Will it replace some type of knowledge work? Absolutely. Like, I think when it comes to, making standard websites or WordPress pages or simple applications or like one-off things, will it replace that work? Absolutely. Will it replace deep, novel technical work? Pretty skeptical.
Yeah, that's pretty interesting but I guess one of the things that you were talking about was, the LLMs are only good if people can actually fix the code, right? Like if it breaks, they fix it, they try to build a system out of whatever code is being written. What I'm curious about is if the new generation of engineers is just vibe coders, right? Because that's this new trend now where it's like you open a code editor and you just allow it to flow through your code. You fix the bug, you press accept, you copy paste, you recopy paste, and that's just like the new wave of software engineering. How are those people going to fix the bugs if they don't even know what the bugs are, if they don't know how the code is working? Like, I'm really curious if you think like that's even
I don't
possible.
I don't know. I actually don't know. I mean, I'm just being honest, mostly because that type of way of doing things, maybe some that will listen to this will call me old and dated, and that's fine. But that's so foreign to the way that I would think about solving problems that I don't even know what to say, right? I mean, it's not how I would ever solve a problem, in the sense that, to me, I come at it from more of a practical thing. How can these tools make me faster? Right. So it's like, it's not going to write all the code for me, but how can it make me faster? How can it write tests for me? How can it make refactorings faster? How can it make like migrations faster or something along those things? How can I like bend it to my will and make me faster? That's the way that I think about it. Do I think about opening an editor and being like, okay, this is my to-do list for today. Go and just, I don't know, do it and then report back and I'll edit it. I mean, I let alone code. I do a fair amount of writing. It's like I've written blogs and I do writing for my current company. And I don't find LLMs that useful for writing either. I mean, it's just for the same reason, in the sense that, like, to me, LLMs are good at summarizing and like taking a first pass over things. But what I find so far for myself is that if I were to like give an LLM an outline of a blog that I would write personally and feel happy about shipping, the text that comes back feels so artificial and foreign that I spend so much time editing the text that I might as well have just written the text in the first place, right? And that's actually how I feel about a lot of the code generation. It's subtly broken in many ways, such that I have to go fix so many things that, at least so far, it does not feel like a net positive for me. Where it is a huge net positive, I have found, again, is less in the code completion aspect, but more in the chat aspect, whether that be built into Copilot chat or Chat GPT or something like that, where it's like, I'm working on this. Help me, whatever, like tell me about this SQL thing. Oh, I forgot what a left join is. Help me with that. Or just like tell me some stuff that I find I save a lot of time. So that's what I'm saying. Like, I'm not shitting on this technology. I think it's very powerful. I just think that right now we are in a huge bubble when it comes to all of this AI stuff, and people are still figuring out like what are the good use cases, and of course the technology will improve over time.
Kind of going back to what you were talking about with like rigorous software and like good software, I guess for someone who might not have worked in that environment, what is like a good rigorous like piece of software like look like? What are the components that go into that? And what do you think like specifically, like if we were comparing like let's say like Amazon or like the startups of today to Microsoft, like what do you think has been lost? Has there been an increase in velocity but a
Well,
loss in like quality?
so let's take Amazon though, because again, this is complicated, right? It's like I joined AWS in early 2010. It was a chaotic startup environment. Amazon today in AWS is a very mature organization. I mean, it's like they've invested in Rust. It's like they write formal proofs for their systems. I'm just saying, it's like you can't even say that one company is a certain way because things evolve over time. I mean, Amazon has invested a ton in very rigorous processes. Again, I haven't worked there in a while, but I know just from reading and viewing what they do that they are very rigorous now. They have to be. I mean, they're absolutely huge. So I just want to say that things evolve over time, and this comes back to what I was saying is that what does rigor mean? Okay, we can talk about that, but like how rigorous do you have to be? Is honestly typically it's a function of what is the impact of failure. Right. I mean, it's like, are you writing a consumer app, that serves ads and that only 1,000 people use? It's like the risk of failure or the implication of failure is zero. Are you, like a Google or an Amazon where you're hosting, the majority of the entire world's data, and you basically have to have like a nation state security profile, right? I mean, very, very different. So to me, a lot of it is you have to start by trying to say, what are the implications and the risks of getting things wrong? And then you have to work backwards from that to say, like, how rigorous should things be? If I dig into your question about what does rigor mean, I mean, again, it's like situationally dependent, but I think there are common themes around test coverage, like how well is the code tested? And even that is a complex question, right? It's like, you can have a code that has 100% coverage, but has tons of bugs. So, this is a very nuanced topic, but like in general, how testable is the code? How brittle is it? How easy it is to change and like feel confident that you're not going to break it? There's implications here in terms of language and systems. Again, I'm not going to get into language flame wars, but just there's some high level decisions around, is your language statically typed? Is it dynamically typed? It's like, what are the guarantees of the language that you're using in terms of whatever memory safety or thread safety or like those types of things. These are complex decisions that lead into this rigor idea. But for me, a lot of it honestly comes down to how testable is the code? Like how confident can I feel that it's working? And more importantly, how confident if I change something, am I going to break something? Meaning, like, how confident am I in my test coverage? And that's not, again, getting into percentages. It's mostly just a feeling of like, if I change this thing, can I deploy it? And how confident am I going to be that something is not going to regress? And I think, again, you can work backwards from languages and frameworks and testing practices and all of those things to like get there. But I'm going to say this time and time again, that this is a very nuanced conversation, and there are no right and wrong answers. Like everything here is very situationally dependent on your specific situation.
Yeah, those are really, really good points. So, kind of one thing I would kind of want to transition into is Envoy. But before we do that, I know that the impact that Envoy made was very heavy on microservice stuff. So, before we kind of go into that, I want to really talk about your opinions on monolithic versus like microservice patterns. Because I know in the software engineering world, that for some reason is kind of still a small debate. I've seen some podcasts, staff engineers, for example, at DoorDash talking about their opinions on this. And I just wanted to get your opinion on what's kind of the trade-offs between a monolithic and a microservice kind of
Yeah.
architectural pattern, and why is it that that's like still a debate today, basically?
I mean, there was a joke that I saw very, very recently. I forget where, maybe it was on LinkedIn. I'm not sure. But the joke was basically along the lines of that every company at scale is either trying to move from their monolith to microservices or move from their microservices to a monolith. And I found that very funny because it's actually true. And the takeaway is that building software at scale is very hard. It does not matter actually whether you use a monolith or a microservice. It is hard. There are hard problems doing both. So to get back to your question in terms of the trade-offs, I guess the quick version for your viewers that might not even know what microservices or monolith are is that monolith is saying that you're going to basically have one giant code base that does everything, right? So it's like everyone commits to it. It's like all the code for your entire system and service. It all goes in there. Microservices is a way of breaking it into different pieces and then having those pieces talk over some type of API. And the theoretical idea is that because these systems talk over an API, they can evolve independently, they can be written in different languages. It's like things can move a bit more freely. What I'll start by saying is that microservices are human. They're a solution to a human problem, not a technology problem, right? And by that, I mean, as the number of people working on a system go up, inherently the coordination costs go up, right? It's like you have merge conflicts. How are you going to deploy the 77 changes that people have put in? And like, how do you know if something breaks, who actually broke it? So it's like, these are all human problems. They're human coordination problems, right? So, in terms of the trade-offs, I think the pros of microservices are what the proponents say. It's that as long as you have an API, that is well structured, and you're using, a language independent API definition system, whether that be like a open API or like a Swagger or, gRPC or protobuf or something like that, you can evolve these systems independently, have them be backwards compatible, and they can be written in different languages. They can move different times. They can change their implementation as long as the API is the same. You can now solve the human problem by having these teams that can negotiate over a contract, and then they can evolve independently, right? So that's nice in theory. With that brings a huge amount of technical problems, primarily around observability. As these systems get more complicated, it's like, how do you know which parts are broken, right? And then networking, and that's where most of my background is that you have, the example that I like to give is you have like your fancy ice cream store service, right? And like your monolith is going to make the ice cream. It's going to scoop the ice cream. It's going to handle payments, like whatever. It's pretty simple. It's all in one code base. Suddenly, you decide to be exciting and, switch it into like a ice cream making service and a payment service and like a user tracking service and like a flavor service. And suddenly you got to like all these networking calls for someone to get ice cream. I mean, it gets really, really complicated really fast, and things tend to break. So the networking problems get exponentially more difficult. So on one hand, with microservices, you're trading this like easier human problem for a lot of really difficult infrastructure problems. For companies, Facebook, I think, being the most well known, who have, at least to my knowledge, have mostly stuck with a monolithic architecture. They have a different problem, which is now you have tens of thousands of developers that are basically committing to this one code base. You have to invest in source repositories, like just dealing with source code changes, automating deploys and rollbacks and like all of these things. I mean, it's really hard. That's a long way of saying that they're both hard. And it just, as people scale, it just gets hard. It doesn't matter which way you're doing it, which is why that joke is true. Anyone at scale that has a monolith is unhappy and they're breaking it into microservices, and anyone that has microservices is unhappy and they're trying to like get rid of microservices. It's just hard.
So would you say that like when you're like in a monolith architecture, are people kind of playing it safe basically because like they're worried about all the networking like things that they have to deal with in a microservice architecture?
It's not playing it safe. It's just, again, this is my personal opinion, is that when I hear about a startup of even moderate size that has a microservices architecture, I immediately question what it is that they're doing all day, because it's complexity that doesn't make any sense. I mean, it's not adding to business value. It's just adding complexity for no actual reason. Now, at a certain point, the monolith starts having problems, right? It's like whether they're people problems or deployment problems or whatever. The code base, it's like it starts to, you want to split it for scaling reasons. It's like one piece has to scale one way and one piece has to scale another way. Like these are real reasons. But before those reasons exist, to me, the monolith is just vastly simpler. It's like one code base, one deploy. At my current company, we're using effectively a monolith, and some of the stuff in there, it's like kind of questionable. It's like this really should not belong together. But you know what? It is what it is because we're a startup. And I think that's just the way that it goes. So to me, again, it comes back to being pragmatic, just in terms of, I'm focusing on solving business problems. And if what I'm doing is not solving a business problem, it doesn't seem worth working on. So,
Yeah,
yeah.
I'm curious. So then getting into being at Lyft, what were Lyft's kind of like motivations for making the transition specifically? Because I mean, I forget how big Lyft was at the time, but
Yeah.
you could say medium to big size
Yeah,
company
no,
by that time.
I would say medium. When I joined Lyft in 2015, the whole company was probably, I don't know, 300 people, and then there was less than 100 engineers. With that said, 100 engineers trying to work on a single code base written in PHP is not so fun, right? Because again, there's a lot of factors here. PHP is not strongly typed. So it's like very easy to have certain classes of bugs. You have 80 developers trying to make changes to this one code base. You have to figure out how to sanely take out deploys, figure out if anything's broken, then like roll it back, and then like revert changes and then roll forward. So, Lyft was already in a situation where deploys could take a day or two because like go out, something's broken, revert it, deploy again, do all those things. So, Lyft was seeing slowdowns. Could that have been fixed on the monolithic code base? Sure. So I think there's two factors there. One is at that time in 2015, microservices were all the rage, right? So it's like that was the thing that everyone did. So that's part of it. And two, I think as was not uncommon during that time, is that you had these very successful companies that were originally written on basically scripting languages. And again, there's some reasons why at scale that becomes difficult just with classes of bugs that are showing up that would have been caught some other way. We saw this obviously with Twitter. The thing was built on Ruby on Rails, and then like almost every company of that era started in a similar way, right? Where it's like they started on some PHP or Ruby thing, and then they ended up moving to something else. So I think Lyft had a bit of both. It was a people problem. It was like a realization that, I don't know, maybe PHP is not the right thing to do here. But again, you look at Facebook, that's an extreme example of going the other way. I mean, it's like Facebook said, we're going to nope, PHP. It's like, we are going to do everything to make that work. And if you look at what Facebook did to make it work, it's a monumental engineering achievement, right? I mean, it's like they built a new, JIT runtime for PHP. They wrote static compilation things. They wrote like deployment mechanisms. They wrote all of these things. It shows you that with enough willpower, you can solve almost any problem. And there isn't really a right or a wrong way. I mean, like Facebook's been very successful, right? Is that wrong? No. I mean, it's like they solve the problems and they're extremely successful. They put a huge amount of effort in, and the effort of like doing that versus maybe doing microservices like a Google or an Amazon or something. Is it more? Is it less? Is it the same? Who knows? It's not orders of magnitude different. I mean, it's a huge amount of effort either way.
Yeah, that makes sense. That makes sense. And so now, Lyft was trying to transition to this microservice kind of architecture because it seemed like that was what they were trying to do. They decided to take that route versus like the Facebook that took the monolithic route. And then that's where the Envoy proxy comes in, right?
Yeah.
And so, yeah, kind of for the viewers that don't know like what a proxy is, right? So kind of the way that we understand it and is it's just this middleman that serves between your external services and your internal services. And by building this proxy, you guys were able to basically allow for more secure communication, native observability, and just a bunch of other great things that later on cloud providers like AWS started building on top of. And so, yeah, I just love for you to kind of now start talking about that transition to building Envoy and just how did that idea even come to fruition? How does one even build something like that from the ground up and know that that is the route to go to approach the microservice problem?
Yeah, so I guess first thing, just to step back briefly, like what is a proxy? Just for those that might not know. The simplest way is to talk about examples that people know. Like everyone, you go to Facebook, you go to Google, you go to, whatever service of choice. And, you're going to www.foo.something or api.foo.something, right? And this might be obvious, but just going to say anyway, it's not like when you go to these things, there's one computer, like, resolving that query or that web page. When you go to Google or whatever, ChatGPT or one of these things, it's not like there's one computer sitting there that's like serving your request and doing all of these things. These are typically built on, coming back to the microservices thing, they might be built in different components where maybe there's whatever user services and other components of the system that are building that aggregate whole. And the proxy layer is typically, it's a translation layer that says, given this typically HTTP path segmentation, where do I go to actually get that information? And that goes not only from the edge, but it can be internal too, right? So it's like at every layer, you're saying, okay, I got to get this logical name, fine. Now, where do I get the actual thing? And that involves load balancing, figuring out how to move the load across multiple machines, how to do retries and fault tolerance, and how do I observe what's going on, and maybe how do I do security and RBAC and mutual TLS. The list goes on and on and on and on of like the things that this layer might do. And really, anyone building these systems needs this in some way. There's always going to be some kind of load balancer or proxy there. Envoy's not the first. I mean, the projects that are most similar to Envoy would obviously be Nginx and HA Proxy. They're 10 years older. Those projects have been around for 20 or 25 years now. And I think, how did this come about is that we built a proxy at Twitter in the 2012 timeframe. And that was mostly because at that time, Twitter, and I'm going to call it Twitter and not X, Twitter during that timeframe, it was pretty like technology forward, meaning it was investing in newer standards. Like at the time, there was Speedy and HTTP2 and, the precursor of Quick, and just like Twitter was writing some of its own software because it wanted to be more on the forefront of how the internet worked. So it wasn't like existing software would do what they wanted. So Twitter was willing to invest in that area. And as part of that, I built a bunch of that software and I got a lot of experience of scaling and observing and all of those things. And since Envoy has come out, there have been a lot of reasons why it's become very popular. The main difference between Envoy at the time, now Envoy's almost 10 years old, but the main difference between Envoy and Nginx and HA Proxy, which at that time were 10 years old and now are 20 years old, is that HA Proxy and Nginx were written originally during an era of, I'll call them like fixed data center resources. In the early 2000s, people would have machines that they would be stood up, they wouldn't change very much. That's the way things were done in the late 90s and the early 2000s. Enter the, late aughts and early 2010s, and now we're talking about containers and Kubernetes and like infrastructure is moving, it's coming and going, it's auto scaling, all of these things. And Nginx and HA Proxy at the time were not really built for this dynamic changing world. They were built for this static world. And Envoy, its main contribution initially was that it was built from the ground up to support this auto scaling, constantly changing world. And that seems subtle, but there's actually a huge difference in how the software works in terms of how it's configured, how it's dynamically updated, and all of those things. So Envoy became popular for a variety of different reasons, one of them being open development and community and GitHub and all of that. But really, it was its core reactive API and its ability to work in these very reactive, highly changing environments. And that's why Envoy was initially so widely adopted and why a lot of people moved from Nginx or HA Proxy to Envoy as they migrated into these constantly changing cloud native environments.
I'm curious, how does proposing a project of this magnitude even go? So you're at Lyft and you realize there's this problem. Is it a bunch of engineers are just complaining and just like everyone's like, we need to do something? Or
yeah, I've said this a couple of times that Lyft should not have allowed me to do Envoy. It's kind of dumb, actually, in the sense that At the stage that Lyft was, it was questionable as to whether it was worth the risk of actually letting me go off and doing this. Would it have enough business benefit? As I said, everything ultimately comes down to business benefit. We're not writing software for fun, at least not in the corporate environment. I mean, it's like we're doing it typically to make money. And is there business benefit? And at the time, people asked questions, rightly so, in terms of, can't we use Nginx? Like, can't we use Proxy? If we write this, should we write it in Python? No joke. That actually happened. And, those are legitimate questions. It's like, those are questions that should be asked. Maybe not the Python one, but, like the rest of them are.
Yeah, I was gonna add, because we read something where apparently someone just said, hey, like, why don't you just write a simple proxy in Python?
It happened.
And
Yeah, it happened. And, that one I don't think is legitimate, but the should you use Nginx, that's a very legitimate question, right? And, I think there was previous experience from Twitter. There was a bunch of us had come over from Twitter, so there was some prior knowledge of all of these things. And, they gave me a lot of rope to hang myself with. And obviously it ended up being a good investment and a good bet, but it could have gone badly, but sometimes these things are risky. I don't know, I mean, I'll say it again and again and again, is that there's just no right or wrong answers here. I think someone can make a strong argument that Lyft allowing me to do that early on was kind of silly. It wasn't worth the risk. Like, the business impact wouldn't have been big enough at that time. Looking back, probably was, it was a bet that I think paid off for them, but certainly not a slam dunk. So in terms of the project approval, it's a pretty small company back then. It was a pretty fluid situation.
Kind of digging into what was going on with Envoy in the early days. So let's say this project was kind of, given the green light to go. I read somewhere that you were kind of doing like a lot of the work, and this was just an intense period of working on this project. What was that like? So you're building this entire thing from scratch. Like, were you given a lot of resources to do that? And just the journey to open sourcing. I'm curious, like, what incentivized the open source decision?
I mean, let's take the first part. What was it like to work on it, and resources? I mean, there was no resources other than me, but I mean, they were paying me money, so it's like, for them, that's a big resource, right? I mean, it's like they're letting me go and work on this. And look, any time, at least in my career, that I've gone off and gotten to do greenfield stuff, I mean, it's still a lot of fun. Those empty source files, right? That's when software engineering is the most fun. And then there's the 98% of the rest of the time when you're fixing bugs and refactoring and doing all the other stuff. But that's life, right? So, in the early days, it was just writing code and trying to get to a minimum viable product as fast as possible. What's the first thing that would provide value to Lyft? And I think at the time we thought, well, we've got this burgeoning microservice architecture. At that time, this is a long time ago, the offerings from AWS in terms of load balancers and visibility and all this stuff was pretty bad. So like, we don't even know, I mean, it's like, where are the requests failing? What's going on? No one knows, So even from the beginning, Envoy was very much an observability focus. And the first version was like, can we just stand up a proxy in front of the existing small number of Lyft services and just start showing where are things failing? It's like, what is going wrong? Did that had a lot of value, and then we moved into, okay, well, there's this service that's failing a lot. Can we put it there? Without thinking about it that much, okay, well, now you have a service mesh, right? I mean, it's like you have this thing talking between both pieces. And then after that, it's like, again, I'm like dating myself, but back then everyone was using MongoDB and MongoDB was always falling over, So it's like, what can we do to like fix MongoDB? So you wind up working on that for a while. For me, it was very much, let's provide value, like let's fix problems and help people. And I think that's what made it successful. I mean, what made it successful is, as I've said several times, I'm very customer and impact focused. It's like, I want to be working on things that help people. And if I'm not doing that, then I'm not working on the right things. So it was a fun time at Lyft because people had lots of problems and I was able to help them. And that's what really drives me. So that was really fun. And that was, 2015, 2016. And I think coming into the second half of 2016, we you just had a discussion around, we've put a lot of effort into this thing. I don't know, should we open source it? It's not like Lyft is going to sell the thing, so let's do it. And as I've written about, me, I was very naive about what it means to open source something and have it potentially be successful. Like, we didn't know. I didn't know. I mean, I dabbled in open source, but I didn't know anything about being a maintainer or any of that. And, so we put it out there. I worked a lot in documentation. We did a release, and as I've said a couple of times, I remember, on the night before the day that we open sourced it, I think I said to my wife, wow, it's like, this will be so amazingly successful if we can get like one company to use it. That would be so good. I would be so happy. And obviously since then it's used by almost everyone. So I mean, it's a fantastic personal achievement, right? It's like it will probably be the defining moment in my career to do something with that amount of impact, and it's been an amazing experience. But it hasn't been without its challenges as well.
And one thing I wanted to ask about is, so you said at the time there wasn't a lot of observability at that like proxy like layer.
Yeah.
What I'm really curious about is, I just recently read something with Laith the other day that was saying like AWS App Mesh, which was basically built on top of the Envoy proxy, is now migrating over to ECS kind of like support. And then that's now when CloudWatch can be like used with all these other things to like improve the observability of your systems. What I'm curious about is, at that time, did CloudWatch exist? I haven't really dug into that, but like, what was the observability outside of like the Envoy proxy?
I mean, at the time, this is going back to the around 2015. Obviously, people had metrics and logs, and there was different metric systems. Whether, I think, Grafana came out during that time, and Graphite, and then of course lots of companies followed on with their metric solutions, and Splunk was around that time for logs and all of that. So it's not that those things like didn't exist or companies hadn't built charting and metric solutions. CloudWatch did exist during that time. But CloudWatch was very expensive, pretty limited in its functionality in terms of whether it could do even like percentiles, like P99, like tail latencies. I don't think it even supported that during that time frame. So fairly big gaps, like in terms of just understanding what was going on. By understanding, I mean, okay, you're making requests. Are they failing? Are they succeeding? What's the latency percentiles at P50 and P90 and P99? Like fairly basic stuff. It was very difficult to do that. So a lot of what people were doing at the time was all custom, right? It was all like everyone had their own things, emitting their own metrics and all of those things. And the observability coming out of existing proxies like Nginx or HA proxy was fairly limited. Again, mostly just historical. Nginx and HA proxy are great projects. I'm not bashing them. It's a different era. So I think the focus on getting people more information was a big early focus. To your point, over the last 10 years, we could spend a whole episode talking about service mesh and all the complaints about it and performance and blah and complexity and all of those things. And honestly, I'm not going to litigate that. I think what we've seen a trend, which is a trend that I called out and I said would happen a long time ago, is that a lot of this functionality over time is moving into the platform, right? Which is where it should be. I mean, it's like, I shouldn't have to run a sidecar proxy to do all this stuff or get all of this information. It should just be built in. It should be built into Kubernetes or ECS or like whatever other system I'm using. And that's the trend, right? I mean, it's like the trend is to move more and more and more of the functionality into the platform, the thing that runs your containers or the things that runs your functions. And I shouldn't have to deal with like retries and observability and all. It should just come out of the box. And that's what's happening. So when you see a lot of these announcements of like, this whatever's moving to ECS or this thing is now being built in or whatever, it's following that trend where people expect this functionality to be there out of the box.
I think that you wrote about pretty extensively as well was you kind of talked about towards the latter end of working on Envoy, one of the difficult things you dealt with was like the burnout of managing sort of the competing interests of managing like open source project while also managing all the internal use cases for a Lyft and kind of working. So what is that like having to do both at the same time? You talked a lot about leverage. I think that was like really interesting.
Well, I think that there was a period of time in which Envoy was really becoming popular. I mean, it was getting very wide adoption. So there was a big support burden of whatever feature requests and bug fixing and all of those things. And at the same time, obviously, I still worked at Lyft. I was still responsible for helping Lyft and do all of these things. There was a period of time in which I was doing two jobs, and I have a high tolerance for stress and like work pain, but it got to the point in which it was getting pretty bad. And I think that a couple of things happened. I think that I had my first kid around 2018 timeframe, and that was a good mental reset. And I think to your leverage point is and I hate admitting that this is how the world works, but it is as my industry stature increased, my ability to work with Lyft and say that we have to come up to some kind of compromise here, that's going to be more sustainable. I think that so I was able to, I don't want to say like negotiate, but just like compromise over a way of getting to a place where I was doing maybe more open source work and less of the day to day of like some of the internal Lyft stuff.
Yeah, and I guess for someone who's kind of looking at your situation and like, I mean, even just you like kind of looking in retrospect, do you think you would have done like Envoy in a different way? Like, do you think you would have put more emphasis on the open source or, would have negotiated, let's say, earlier for it?
No, no. And I'm this is like another hour episode topic, but there's lots of dialogue and verbiage around, do you work 80-hour weeks? Do you work 40-hour weeks? All of those things, right? I mean, again, I like there's no right answer. I mean, it's like everyone has to find their own way. I'm again, I'm somewhere in the middle, which is I think work-life balance is important, and I generally in my career I've had pretty good work-life balance, but I do feel that sometimes, if one wants to accomplish big things, one has to sacrifice. And no, I don't know what I would have done differently with Envoy. I don't know what it could have been done differently, right? I mean, it's like it was born out of a particular situation. It became very popular. If I didn't nurture it in the way that I did in the time frame that I did, I don't think it would have become what it was today. So no, I don't think I would have done anything differently.
I'm also curious because Envoy was this like massive project, and I mean, I'm sure you get this question a lot, is why didn't you start a company like straight
Yeah.
purely around Envoy? What was kind of like your headspace with it? Like, were you okay with like leaving the project? Were you looking to new things? Like, what was the headspace? Did you want to be the Linus of Envoy or something
No,
like that?
yeah, I think for me as a person, I actually I get kind of bored doing the same thing over and over again. And I'll be honest, like I love Envoy as like my child, but I don't work on Envoy very much at all anymore. And it's not that I don't love it and I'm not willing to help and I'm so proud of what we've accomplished. It's just that I've never worked on the same thing in my career for more than a few years at a time. So honestly, working on Envoy for like 8 years, longest I ever did anything. So, and I just tend to get bored. And so for me, a lot of people do ask about Envoy and the money and the company and all of that. And look, like I'm a super privileged person. I'm not poor. It's like, could I have started a company around Envoy and made a bunch more money? The answer is probably yes. Would I have been working on things that I have loved? I don't think so, actually. And I think ultimately that's what stopped me, is that if you look at, there have been a number of companies started around Envoy. And obviously, I'm not privy to the exact revenue numbers and all of those things. And none of them are fantastically successful, right? And like a lot of it is mostly because building a business out of a piece of software like Envoy is very difficult. There's no SaaS service. Like it doesn't work that way. It's a proxy that someone has to run, So it's like, yes, maybe you could run a control plane for it, but like mostly it's a services and support business. It's like dealing with field engineering and solutions architecture and a bunch of other stuff. And I'm not saying it's not valuable. I'm not saying that I appreciate the companies that have been started around Envoy. I'm not saying that they're not doing useful work. I just personally find it boring. Like, it's not interesting. And, it's like everyone has to make their own decisions.
Makes sense, yeah. So since it's not super interesting, we should definitely get into BitDrift, which is definitely the more interesting stuff. And kind of before we just start really talking about BitDrift, one of the things I kind of want to understand is, what was that transition period like the spin out of going to BitDrift? Because I'm guessing that, there were some tough points of contention, maybe there was some conflict of interest. It's you're transitioning out of a corporate environment, right?
Yeah.
And I'd love to kind of understand that transition before we actually dig into what BitDrift was at its core.
Yeah, I mean, let's first start, and before we get into technology, let's just talk briefly about how it even came about. As was not uncommon during, let's call it like the late 10s and the early 20s during the COVID era, companies were like doing really well. They were flush with cash, stock markets booming. And I think companies were willing to let people, instead of having them leave, they're willing to let them go and, let's call it, do a startup within a startup, right? Like, this is a kind of a common theme, at least it was for a couple of years. And we were doing that within Lyft. And I'll be the first to admit that it's not possible to do a startup within a startup. It's a fake startup. It's like you're working on the corporate time frame. There's no urgency. It's like, it's not real. And I think, by the middle of, let's call it 2022, end of 2022, it became really clear that we think that what we're doing has legs. It's never going to succeed within Lyft for a variety of reasons. It's not going to succeed because, okay, well, now, Lyft and other companies starting to have issues. They're not going to fund it. People are always going to ask questions like, you're starting a company within Lyft? Like, what does that even mean? It's like you're not working with the urgency of doing it, doing it correctly. So I think by that time frame, we said, okay, like, if we're going to do this, we have to do this. It's like, we have to spin out. We have to make this happen. I'm honestly not going to go into the complexities of the spin out, just because, there's a lot of legal issues. And all I can say is that I do not recommend doing a spin out. It was a very bad experience. And we've come to a great place with Lyft. Lyft is a customer. It's like, I think things are going great. It was a very painful process getting the company spun out. And I do wonder, again, hindsight's always 2020. It's like, would it have been better to spin out? Would it have been better just to leave and start from scratch? I honestly don't know. It's kind of like the monolith versus microservices. They're both painful. It's like, what's the right answer? I honestly don't know. But the spin out process was painful. Like, there was a lot of negotiation issues. There was a lot.
Yeah, I was going to ask, especially because one of your core principles is like impact driven development, right? I'm really curious, like, what actually led to you even being willing to do that battle to go into BitDrift, Because, I mean, was it that, like, potentially you just couldn't make a really big impact at Lyft and you felt like you needed more autonomy outside of Lyft and then turn it into something, like, kind of a baby of its own?
Yeah, I think it's what I said, which is that I don't think it's possible to do the startup within a startup thing. I mean, I can't think of any examples like where that has worked out well. I mean, I'm sure there are some, but it's like the only example that I can think of in recent memory is maybe like Waymo or something like that, where it started as like a thing and now they're built some pretty cool stuff or whatever. But I'm sure there are some examples, but like I can't think of any really. I mean, it just doesn't seem like a thing that actually happens. And I think that's because to do a startup, do something new, there has to be a lot of urgency. There has to be scrappiness. Like, you have to move fast. And those are honestly at odds with how corporations work. So I just don't think it's possible, quite honestly. So I think for me, it was getting to the point where, I was going to leave Lyft one way or the other. So it's like, this is interesting. We could talk about it more about why it's interesting, but I'm willing to try. Let's do this. Let's see if we can make this happen. But if we do this, it's got to be as a company, not as like a like a fake startup type situation.
Yeah, one of the big themes of a lot of the things that you've talked about, just kind of like zooming out, has been the importance of observability, just like this massive concept. And obviously, it's at the root of what you're doing with BitDrift. So, for someone who isn't very experienced as a software engineer or just anyone curious, what is really the importance of observability? Why can't we just have basic log statements scattered throughout the code base and then just like figure it out? And specifically to what BitDrift is doing
Yeah,
with mobile specifically,
right.
why is observability such an issue there?
Yeah. So let's talk and just for 30 seconds, like what is observability? And even setting aside the technologies, like whether that be logs or traces or metrics or whatever. Observability is just the idea that you can understand what's going on in your system typically in real time, right? So it's like you can understand why is this request failing, or like why is this user, not able to do this thing, or why is it crashing or something along those lines. And there are technologies that people have used to achieve that, whether that be logging or writing metrics or like distributed tracing or those kinds of things. But the concept of observability is really just, how do I know what's going on in the system at any given time? And this is a thing that's near and dear to my heart, because as I said, microservices, they increase the need for observability because there's so many additional points. And one thing that I want to be clear about, which we haven't talked about yet, is that even with a monolithic architecture, if you have an application that has phones and web browsers, I would argue that no matter what, you have a microservice architecture, right? Because every phone is a little node in your distributed system. And if you have millions of phones and tablets and all these things that are talking to your backend, it's like, well, how do you know what's going on, right? I mean, it's like typically you don't. So again, observability is the idea of just like, how do I know what's going on? How do I know if failures are happening in my backend? How do I know if failures are happening on the phone? And the example that I like to give, just in terms of the importance of observability, particularly mobile observability, is lots of backend people will say, I have like a 99.99% success rate. It's amazing. I can show all these things. And then, the number of times in my career that everything is fine on the back end, but like some JSON is sent to the client and then the client's crashing and it's like 100% crash rate, like you're down, like your application is down, right? But like everything looks great on the back end. It just shows the importance of like, how do you understand this end-to-end system? And the way that people have done this for 30 years has not changed all that much. There's been a move recently to move more into what are called like wide logs, and I can get into that. But for the most part, the way it works is you emit some signals, some logs, some metrics, some traces. You send them to a provider, and the provider stores them and then allows you to query them, right? Sounds simple. But as has become notorious with lots of memes, the amount of money that people spend on these systems is, ginormous, right? And it's expensive on many layers. It's expensive because you're producing the data, you're transiting it over the network. There's non-trivial networking costs. And in fact, if you're generating this data from a mobile application, this may seem counterintuitive, but in many applications, the analytics, the observability data can be larger than the application data, right? And the reason that's important is that even in the current day, when you're out on a mobile network and you're using your phone or whatever, the connections can be spotty. And if you are sending so much analytic data to some backend system that you can't even receive your application data, the actual application experience will suffer. So I just wanted to point out that even the act of observing systems can impact the system, right? So there's lots of costs. And companies like Datadog and Splunk have just become notorious for charging excessive amounts of money, mostly because you send them all the data, they index it, they store it, they like do all these things, and then you pay for that. And what this has led to is a world which, as an operator, I experienced, is that no one's happy. you're grumpy, right? Because your bills are so high. And then you're grumpy because someone in finance is telling you to stop logging and stop emitting metrics and doing all these things. So you spend less. So you can't solve the problems because you're paying too much and you don't have the data that you need to actually solve the problems, right? So I think where BitDrift came from, and just the very quick version, is we take a very different approach to observability. And what we do, instead of basically sending all the data in, is we have a very smart SDK and a control plane, and we send real-time instructions to all of the clients. And those instructions can be, look for this log and look for that log. And then if this happens, actually emit this metric or dump a bunch of data. And we actually have a ring buffer that runs on all the clients and stores all the data locally. And what that means is that by default, all the computation's on the device. It never leaves the device. But when I want more information, instantaneously, I can send instructions to a fleet and I can say, if this happens, send me a bunch of data. And now I get 1,000 times the data when I actually need it. So it's a fundamentally different approach to observability. And basically, it pushes the computation out to the edge and it only ingests the data when I actually need it to debug different problems. So that's BitDrift in a quick summary.
That's a really good explanation. One thing I'm curious about though is if everything's on the edge, do you deal with any like problems with like doing surveillance? Because you're basically doing log surveillance at the edge, right?
Yeah.
So are there like any data privacy issues? Like how does that actually
Yeah,
work?
that's a fantastic question. If anything, I would argue that companies that we work with like our model better because the data never leaves the device, right? And it's under the control of the user owning the device. So in some cases, especially when it comes to PII, like we have interesting features where, for example, so as I mentioned, we have this system where you can define these workflows. It's actually a finite state machine that we compile on the server, send to the client. And you can think of it as like, whatever, request 500s, then user goes to this screen, then like 10 seconds happens, then like dump all the data or whatever. And we can do matching and various things. For example, we allow matching on the device in request bodies and response bodies, but we never send those bodies to us, right? Because those bodies typically will contain PII, right? But because we can do the processing on the device, we can actually have access to really rich information. So we have some interesting plans here in the future around things like end-to-end encryption and other things that we think that we can do to even further increase data privacy. But we actually think that our model in some ways is better for data privacy because this data in many cases never leaves the device.
I'm curious, what are the unique sort of disadvantages of having to build observability for mobile, especially compared to
Yeah.
like working with servers?
Yeah. I mean, I think in general, is the spotty networking that we talked about before. It's the fact that on mobile applications have very little control over when they're terminated and when they're suspended, right? It's like on server, for the most part, things run until they run. Well, I mean, maybe they'll get preempted, but everything is very controlled environment. That's not and networking generally works on server. So mobile is really just this constrained environment. It's a very heterogeneous environment. Apple, Android. On Android, there's 8,000 different providers and like operating system versions and hardware models. I mean, there's low end devices and high end devices. It's a very tricky situation. So it is really this like sporadic networking, heterogeneous environment. Can be killed at any time. There's lots of challenges.
And specifically for you, like I'm curious, what about like I guess for you, like on a personal level, what was your personal motivation for tackling the problem specifically for mobile? Was there some like application you'd worked on at Lyft where it was just like, this is a mess, I need to go after this?
Absolutely. Lyft built a lot of technology. I mean, this technology was built and deployed at Lyft to help Lyft debug things. So, we built it there and we were relatively confident that we could continue to build on it. But I think it really comes down to what I was actually saying about you have a 99% success rate on the server, but your app is crashing. At the end of the day, if you're running an app-based business, which most people are these days, the only success rate you actually should care about is the one on the app, right? It's like, it does not matter what your server success rate is. If your app success rate is 80%, you're losing 20% of your business. And I think that we have advanced a lot in server observability, which is fantastic. But in some sense, it's not actually where we need to be looking. The most important place is more on the RUM side, the real user monitoring side. It's like, what are the users doing? And I think a lot of reasons that people haven't done it so far is it's so hard. And this comes back to what you're saying, is that like, could I keep working on Envoy? Sure. But this is really interesting. I mean, it's like we are solving a lot of very difficult problems just around, again, how the finite state machine works, how the tracking works, how the ring buffer works, how all the stuff works. It is a very complicated and challenging system to get right. But I think it's very useful. And I think that, we're solving two different problems at the same time. One of them is getting people the data that they need at a reasonable price point and getting them way more data when it matters, right? Because that's the key point, is that if I have to define all of my data ahead of time, and then I have to, like, we didn't talk about mobile challenge. One of the mobile challenges is that any changes, they take 2, 3, 4 weeks to deploy, because you have to do a patch, submit to the app store, then people have to update, right? It's not like server where you just like make a change, you can deploy 10 times per day. It's not the way that it works on mobile. So on mobile, if you have a problem, you're looking at 4 weeks to go and figure something out, to maybe add a log line, pay for that log line, figure out what's going on. It's an awful situation. So we're trying to basically fix two problems. One of them is not force people to ingest all the data, but also get them way more data when they need it, right? It's like we can say, you log everything, and when you want it, we'll give you 1,000 times the data. And that is probably the most important part.
What is the cost reduction? Because I know whenever you're like talking over a private network, for example, like on AWS, the cost is like lower than, for example, if you're doing like a public network communication,
Yep.
but you're doing it on the edge, right? Which means that really the cost that you're paying is just the in transit cost to like bring it to the server once you've done all the computation like at the edge. What is that cost difference? Like, I'm really curious. Like, how much are you actually saving your customers?
It depends on the customer. It's a tricky question because of what I was just saying, which is that our customers, once they realize the power of our platform, they log way more locally, right? To the extent that that never would have been feasible before. Like sending all those logs to the back end, cost, bandwidth, all those things, like it's just not even feasible. It's not quite apples to apples in the sense that, right, is like no one, once they start using BitDrift, they're not just going to log what they logged before. That would be crazy. It's like they should log way more, right? Because now when they want the data, they can get way more. So I'm just saying it's a bit tricky in terms of the savings, because if you're comparing, it's like, well, what would they be paying versus sending a bunch of like limited log lines and whatever? I mean, again, we have to go do the math. Obviously, depends on the different providers, and AWS charge a lot for bandwidth and a bunch of other things. But it more comes down to the fact that what would they pay if they were actually trying to persist all the logs that they can get with us now? It's honestly not even possible, just because the cost would be so large, or the bandwidth usage for a steady state would be too large, right? So it's, I wish I had a better answer. Maybe in the future we will, but it's not so easy to figure out like what are the percentage savings, I guess.
How do you guys get around I guess, the smaller compute on the device, especially as they ask and demand for more logs?
Yeah.
How do you guys get around the performance of phones? Because I mean, one of the things I've tried working on like mobile applications, and it's kind of messy because there's all sorts of things you can't even account for in the system
Yeah.
that can interfere with your application.
I mean, we have to be very cognizant of performance, and we put a bunch of work into it. I will say that phones are getting very, very powerful. So, you could do a lot out there, especially on the higher end devices. And one of the power of our platform, because it's real time, dynamically configurable, we maintain this bidirectional connection between every phone and our control plane. We can have different configurations depending on the device. So if you're on a very low end device, we can do less. If we are on a high end device, we can do more. And that's the power. It builds on Envoy, right? It's like Envoy was very much about dynamic configuration. We're taking that to the observability world, and it gives us a lot of flexibility in terms of how we structure the system, how we think about the system. But yeah, I mean, it's a concern for sure, but the phones are faster than you might think, and we do a lot of work in performance. All of the SDK is mostly written in Rust. So it's a shared code base that actually runs everywhere. So it's great for performance and correctness and all of those things.
Why didn't you use Python? No, I'm kidding.
Yeah.
There you go. You should have written the whole thing in Python.
I know. I should have. Yeah.
Yeah. But I wanted to expand kind of on this device topic. So I'm just thinking back to our last podcast. One of the things that our guest Gleb was talking about, where he was saying that like one of the biggest things that people don't understand about modern robotics is that a lot of the things and basically the observability behind robotics is like in the cloud. It's not on the edge. I'm curious if you guys are planning on expanding beyond mobile, because you have this whole new wave of devices that do need observability on the edge.
Yep.
Is that the next step for you? Or are you going to stick to mobile observability for now?
So I mean that's a fantastic question. The answer is unequivocally yes. We already have a large customer who deploys an Electron app, right? So that is desktop, but I mean it's very similar to mobile. We've had several requests for working in, I will call it like factory infrastructure industry type spaces. So like whether it be, industrial like 3D printers or vision systems or whatever else. I think there's huge opportunities in like oil and gas and maritime and honestly satellites. And I mean, there's tons of places where this is applicable. Is this applicable even on normal server? Absolutely. Right? I mean, it's like where maybe you want to have like high frequency logging or something in like a local Python service and you want to get more information. The answer is yes. So will we expand out? Absolutely. We're still a very small team, and I think we've started to see a bunch of traction within the market. So I think at this point, honestly, we're laser focused on mobile because we think there's a huge opportunity there. But as a company, will we expand out into other areas? Absolutely, for sure.
Yeah. One like especially I'm thinking about I have a friend who works on like mobile apps, and he says that one of the worst things about developing, especially for like Apple, is that they do these like really weird like code-based search, and they kind of like looking into what you're actually doing into the code base, and they can be very like strict. How do you guys, especially because you guys are doing logging and there's like network communication, have you guys had like a lot of issues with Apple on this specific thing?
No, we are actually. I'm not the expert in this space, honestly. We have one of my co-founders is a mobile expert, and we have some great experts on the team. So I defer to them on this, but they are very knowledgeable about this space, and we go out of our way to do nothing shady at all within the SDK. So no, we have not had any issues.
Yeah, I mean that's awesome. I'm really excited for the directions you guys could go. I mean, even just the general topic of observability is interesting because I mean, I have an ML background, and one of the biggest problems I think we have with ML models and infrastructures is observability. We don't understand the costs. Even one of the biggest issues is just like not understanding like from a GPU, like how much of the GPU cost is happening per token. What are the costs whenever you make an OpenAI?
Right.
Like people don't understand costs in general. So like this observability problem is ubiquitous.
Yep.
So I guess it'd be a crime for me not to ask like, where do you see, because obviously AI now is like the new frontier. Where do you see observability playing a role with AI, and is BitDrift hopefully moving in that direction?
I'll be honest. I don't know enough about the inner details of that space to have a great answer. I think we see a lot of opportunity just in general observability of systems before going after specific use cases of AI. I'm sure there are some. I think where we've had some initial inquiries in this space that I think are interesting that we might go after first is there's a whole area that I'm not super knowledgeable about, but I know, that people want to gather training data of things that happen on phones and all of those things. And I do think one area that our platform could be useful for in the future, whether we offer it as a service or we sell some of the data or work with people, I'm not sure. But if you think about one of the powerful things that our dynamic platform can do in a very similar way as you don't necessarily want to gather training data on every phone and send it back, right? We can do targeted training data capture, like very targeted, based on specific cases or users or something along those lines. So I do think actually that when it comes to aiding in gathering training data or even doing training on the phone and all of those things, I think that's an area that would be interesting. It's something that we certainly might explore in the future.
And I guess, yeah, I mean, even from that, I guess for me, I kind of want to zoom out because you said you started a company like a long time ago. Like that was like the first experience you had. Then you had the whole experience working on open source for Lyft. I'm curious for you, what have been the takeaway lessons of like building a startup compared to working in a corporate environment? What were the biggest takeaways? Because obviously you have a really deep engineering background, but now you've kind
Yeah.
of pivoted towards the leadership position.
I think, as I've said a couple times in different interviews, I think doing a big open source project in some ways is similar to starting a company. It's like you have to, marketing and you have to do selling and a bunch of other stuff. I think the biggest takeaway for me of starting a real company is getting people to part with money is difficult, especially in the B2B space. So, and we're a B2B, effectively enterprise company at this point. And it has taken longer to get the sales machine going and get people to part with money and all of those things than I would have imagined. So I think that's been the biggest learning, is just that, you can have a great product and you can iterate on it and continue to find product market fit and all of those things. But even after you do all of that, getting people to sign contracts is hard. And obviously our goal is to make the product more and more compelling so that them signing the contract just becomes a no-brainer. But it's a different, meaning, I think with open source, there's an easier barrier to uptake because it's free, right? And with a product, it's not. So the minute the finance people get involved and a bunch of other stuff, things get tricky.
How did you, I mean, I guess this is like one of the cool things since you are the sort of the face of engineering or working at the highest level of engineering at the company. How are you spreading the lessons and kind of like takeaways from working at Microsoft? And like, obviously you talked about like the rigor versus like fast approach of software. How are you bringing that to BitDrift? How are you kind of like scoping it into people, sort of establishing that like engineering culture?
We're a pretty small team, and I'm not going to say that this is the best way. I know that people have lots of different philosophies on this. I tend to lead by example, meaning like I'm still in there doing the work, right? So I mean, I think that's the best way, and just in the sense that I think you show what, I mean, at least ostensibly should be done, and then people probably naturally emulate that. I don't really believe like in the edict from up high type approach. I don't think that's very successful. So I'm still a practitioner. I still write code every day. I think from that perspective, I think that's the best way in my experience, is to be in the trenches and actually doing the work.
Okay, and I guess so. The theme of our podcast is always kind of we're the from scratch podcast. So one of the key points we always kind of try to focus on is like what does it really take to build great products or
Yeah.
do great research or whatever from scratch for someone who is wanting to do a startup and let's say especially write like really deep software. What is kind of your general advice for building things from scratch? How much of it is about finding the right team? How much of it is it about getting to an MVP very quickly? That sort of thing.
It's so hard to answer that because I just feel like there's so many variables. I think what's going to be constant is the team for sure. We didn't talk about it a lot, but when I started the company when I was young, the co-founder that I started with, it was a bad situation. That was not, it just wasn't a good fit. I didn't know enough back then to even think about it, but I think team is huge, meaning you need to start a company with people that you're going to be spending a lot of time with and have very complementary skills, and make sure that you have shared motivation and all of those things. So I think team is huge. And then, beyond that, I think people have lots of different opinions in terms of whether things are whether you should like focus on finding the right product and product market fit, or whatever, having like an amazing idea and like focusing on that, or just getting in there and just hammering on a problem over and over and over again until you figure out how to make it work. And I know people have different philosophies on that. My philosophy is find a team of people that you want to work with and find a problem that interests you. And my general take on engineering is, and this may sound odd, is that I don't like really actually believe in invention or like revolution. I don't think anything works that way. I think if you look at the history of engineering and invention and like computing and all of this stuff, everything is kind of like a slight iteration of what came before, right? I mean, it's like there's nothing novel in Envoy. It was just a packaging of a bunch of different stuff executed very well. And I feel like if you look at a lot of companies out there, I mean, some things are novel, some things are not, right? It's like, even to me, if you look at OpenAI and ChatGPT, I mean, they executed amazingly well, but they didn't come up with any of those ideas. I mean, like, those are industry ideas, right? That had been started by Google and other researchers for a long time. Just everything builds on everything else. So I'm of the approach, you find a good team, you find a problem in a space that you think has business value, do some vetting in a space that you want to work on, and you just go for it and you iterate until you succeed or run out of money. I mean, it's like that's my general philosophy.
And in terms of skill set, would you say that a lot of your skill sets came from your experiences or the way that you approached engineering, for example, in your free time? I feel like the answer here is kind of clear based on what you said, because you said you're not really a project person, you're an impact person. Everything you
Yeah.
tried to work on was very impact driven. So for like engineers today, right, that we're in a whole different wave of engineering now in terms of the way that the world works. What would you recommend to engineers who are very early in their career who want to make impact maybe in the future?
My biggest advice for anyone earlier in their career is, in general, is to try different things and learn as much as possible. That is my number one piece of advice, is if it is feasible from people's personal situations, is to work at a small company, work at a big company, like work on different technologies, at least for a few years, like get a feel for different areas and different ways of working, right? Because I think those are very formative. That is my number one biggest piece of advice. When you're asking about me and like my personal motivation, I'm motivated by impact. I'm also motivated, quite honestly, and this is my personal nature, which is good and bad, is I am motivated by proving people wrong. It's like there's nothing that motivates me more than being told that something is not possible. That has been a theme throughout my entire career. So, finding someone that someone said, finding something that someone said is not possible and then go making it possible, to me, those are great seeds of things that will become big, right? Because if people said that it's not possible, it means that it's probably useful and it's hard, right? So I don't know. I mean, it's hard to give canned advice, but my advice is typically work on interesting, hard things and try to learn as much as possible. That's it.
Did anyone tell you that BitDrift wasn't possible? Did you have a lot of like pushback from
No,
people around you or investors?
no, it's just that we're doing things differently, right? It's like we're not the same as every other observability company. We may very well fail. I have no idea. It's too early to tell. But we face a lot of feedback from people, potential customers, which are like, well, but what if I need that data? Like, what if I need that data 2 years from now? I was like, well, I want to talk with you. I want to work with you. But if really at the end of the day, you feel that you need all data 2 years from now, BitDrift is not a good fit, right? So it's not like being told it's impossible. It's more that I think what we've built at BitDrift, in my opinion, is a huge technical achievement. Like, there are things that we can solve for people that honestly blow my mind. I mean, it's like, and I built the system. I mean, it's just like watching the things that people can debug in the field now when they can do it in this way. It is very inspiring. And, I think a lot of people would say, not that it's impossible, it's just that, man, I don't know, that's like so different. That just seems crazy. It's like, wow, we haven't done it that way in forever. That's kind of what I'm saying. It's not that anyone ever said it was impossible. It's just that it's very hard. And like, to me, I'm attracted to those kinds of hard problems.
How do you gauge impact? I guess like you've had
It's
so
tough.
many years
Yeah.
of experience, but do you think like that's been the main motivator for you? It's just been, I've seen this everywhere.
No, it's I think it's very subjective, right? Just what does impact mean? I like you're going to talk to people, they'll give you 10 different answers. Like it might be how much money they're paying you, it might be how many people are using the software. I don't know, and I don't I don't really know the answer to that. For me, if you were to push me, to me it's more people impacted, I guess, right? I mean, it's like I'm not again, I'm a very fortunate person, so it's like I've made plenty of money in my career, but I wouldn't say I'm like money focused. So for me, it's more about people. And when I think about Envoy, it's like Envoy is a piece of plumbing, right? But at this point, I mean, it would not be an exaggeration to say that billions of people around the world are, I mean, Envoy is in their daily experience, right? I mean, it's like billions and billions of people. So that is I mean, that's amazing, right? It's like that's a huge amount of impact. And for something like BitDrift, I ultimately, via helping people develop other apps and systems and make them better, I would like to impact lots of people. I want to make their experiences better, because for me as an end user, I'm sure you all experience this too. The number of buggy apps out there, like it kills me. I mean, it's just like terrible user experience, and I think we can make that better, and I think that will impact people's daily experiences.
Even thinking about like Lyft's competitor Uber. I mean, Uber has so many bugs, and they're a massive company. They burn through capital nonstop, and that's just like the tip of the surface, right? So yeah, it's really cool what you guys are doing with BitDrift.
I commented on it recently. It's like I was checking into a flight, not to call it Delta, but it's like every app has this problem. And it's like I'm like trying to log in to Delta app. I'm like copying the password from my password manager. And I mean literally the app freezes every time. I'm like trying to like input my password, like trying to log into your app. Super basic stuff, but that kind of stuff is pervasive, and it's so hard to debug, and like there's so many angry customers out there, and like we were saying is that if the people can't use your app, your success rate is zero. It is zero, right? So it's like it doesn't matter what you're doing on the back end. So it just I think that we have the ability, even before we go into industrial cases and server cases and a bunch of other stuff, like just to make people's experiences better with the apps that they're actually using today.
No, no
Yeah,
worries.
I was just saying because you're also like building like consumer trust too, right? It's like when a Delta app doesn't work for me, it makes me not want to go on a Delta flight, right?
Correct.
Or like if a United app doesn't
Correct. I
work for
mean,
me, it makes me not want to go on a United flight. Yeah.
that experience was so infuriating to me that it would actually, all things being equal, it would make me not fly Delta. And I think there are many examples of that. Like one of the reasons Lyft invested so much in this is because of Uber, right? It's like, I mean, if Lyft was down or had a bad experience, people would go to Uber. I mean, that's just the way that it was. And I think there's lots of competitive industries like this where it's like your competitor is one click away. So people have very short memories. Or sorry, actually, I think very long memories in certain cases for some of these bugs, and they'll just switch.
I think what's really cool is like there's this kind of consistent theme, like as I've like talked to you about the importance of like software that works. And it seems
Yes,
like even
I
the
agree.
observability thing, it all feeds into it. If we are making faster software and shipping things faster, then it becomes even more important to understand what's actually going on, and to have a positive customer experience.
Thank you for saying that. And I probably should have said this myself earlier, but overall, at the end of the day, nothing pisses me off more than things that don't work. I mean, it's like that's just been the theme of my entire career. And yeah, I mean, that's why I'm passionate about this space is that we should move fast. We should do all these things, but we should be able to fix the bugs when they crop up or know if bugs are happening, right? And that's where observability comes in. And I think a lot of times, we move so fast and systems are so complicated now that there's so many bugs, but they just linger, and then people have bad experiences. And that part makes me angry.
Well, Matt, thank you so much for your
Yeah,
time. It's been a
sure.
pleasure talking to you. Where can
Yeah.
people find you to stay up to date
I
with
mean,
BitDrift and you as well?
these days, that's tough, right? Because all of the social media chaos. I'm on LinkedIn. I'm spending more time on Blue Sky these days, but email is good. Whatever works.
Also, I should add a asterisk. Like, people don't be confused by Matt's LinkedIn. He's a plumber on LinkedIn, but
That's
you
true.
know,
Yes.
yeah.
Yes. Yeah. Cool. Well, thank
But
you
Awesome,
very
awesome.
much.
Yeah, thank you so much, Matt. It was awesome. Thank you, thank you.
Yeah. Yeah, you'll have to like break this into 2 episodes or something. That was
Yeah, we
well,
might just upload the whole thing. People like to watch these episodes. Like our watch time on the last episode was like pretty impressive. So
okay.
yeah,
Cool. All
yeah,
right.
yeah, yeah, cool. But
All right.
yeah,
Well, thank you.
we
Thank you
appreciate
so
you
much.
coming
Yeah,
on.
let me know
Yeah,
when it posts and I can put it up.